Welcome to this session. Lift and shift a web application to serverless. Is that possible, Danilo?
I think so, but I really want to be sure today.
Yeah, I think we will tell you our experience of lift and shifting a web application to serverless, as it says. We will guide you step by step, but first, let's introduce ourselves.
Please.
I start first? Okay. I'm Marcia Villalba, developer advocate for the serverless team, and with me today is
Danilo, and I'm part of the developer relations team, and I'm quite passionate about serverless since the beginning with Lambda and everything that came after.
Yeah, you were the first AWS person that say hi to me, so now I'm showing AWS. Things happen. So let's start with my first experience with serverless, because we are going back in time to 2016, when serverless was in diapers, and I have zero experience with it in production, because by that time, very few people have any experience in production. I was working in a team, and we have to migrate our application to serverless. The most experienced person with serverless was me, because I have played with Lambda and things like that when it came out, so I was kind of appointed to do that migration. I have zero experience of migration. So my team also have zero experience of migration, and we started migrating. One thing we agree with our managers, I still don't know how we managed to agree that, is that we are not going to release any features for 1 year. Yeah, I know. I still don't know how they say yes. So we started doing the migration. 9 months passed, 9 months. We were kind of feature paired with whatever we had before, and we started to go to production. Yes, 9 months to go to production. You can make a baby in that time. 9 months. So we went to production. Everything exploded in our face because we didn't try it before. We had an active application that we were trying to put into production. We spent many months crying and hitting the head against the wall, and finally we got it out. Why I'm telling you this story? Because there are better strategies than that one to migrate to production, believe me. One of the most common ones, after I did that migration, everybody's like, Marcia, you have to do the strangle pattern. Why you were doing that kind of shebang migration? That's so silly. And I was like, well, I don't think the strangler pattern will help me, because we needed to re-platform totally. We were like not really compatible to what we were trying to migrate to. So if we were starting to do the strangler pattern, that is grabbing little pieces of our application and migrating it little by little, we will need to create a whole structure just to do the traffic of route traffic and do a lot of support just to keep this migration going. So I think for this use case, a lift and shift approach will have been better. And what I mean by a lift and shift, meaning grabbing the existing application, touching it as little as possible, go as fast to production as I can, and then start doing the strangler pattern. So that's what I want to show you today. We will present you the strategies of how to migrate a backend, a frontend, and a database with almost not touching the code in a lift and shift manner to serverless. Then we will target some of the most common problems that you will find during the migration. And then we will talk about cost and performance. Because when I started building this deck, a lot of people were like, Marcia, you cannot make a web application on serverless perform as good as in non-serverless environment. I was like, challenge accepted. So I'll show you how I did it. And then we will talk about what next. What is coming after you do the lift and shift? So let's start.
Yeah, let's start to know the application that we are going to migrate today. So the application is an e-commerce platform that sells AWS swag. And in this application, you can browse the catalog. You can pick and choose what you want to see. You can filter the content. You can choose a specific item, and then you can add it into your shopping cart. You can look at the item. You can remove the item from the shopping cart. And that at the end, when you are satisfied with your list of purchases, you can complete and pay and complete the purchase. You can also see the list of the history of the operation that you make on the website. So it's a very typical e-commerce application. And the architecture of this application is a typical three-tier. You have a database. The application is currently using MongoDB as a database. You have a backend server that is implementing the APIs, that is built with Node.js using the Express framework. And then you have a web frontend that runs on the client, on the browser, that is built using React. many of the tips that we'll share today are not really bound to these technologies, so you can also use different technologies and they apply as well. So when you do a migration, you should really write down what are your requirements, because why are you migrating? In this case, our workload is a little bit bumpy, so we have the traffic going up and down very quickly, so we want an environment that can scale down to 0 and can scale up automatically if there is some workload, some customers to our shop. We want to configure as little infrastructure as possible. We want really to don't focus our effort in managing the infrastructure, but in managing the applications and the features for our customers. And we don't want to manage the availability of the application. This is really a key point with the cloud architecture, so that you can offload the management of availability, of replacing what is broken with something that works, with fixing automatically when there is an issue. And this is something that serverless architectures do very well. And as Marcia said, we want to do a lift and shift. We don't want to change the code unless it's really, really strictly necessary. So we want to do the minimum amount of changes. As a bit of a spoiler, this is the final architecture that we will build. So with the database, with Lambda for the backend, Amplify, and other tools. But let's see step by step how we can arrive to this point. So let's start building. The project that we are going to build, we want to automate everything as much as possible. So we are going to use the AWS CDK to describe and implement the architecture of the application. We are going to use TypeScript for the AWS CDK so that we can express the architecture using the TypeScript language. This makes sense because most of the application is not JS, so it's JavaScript. And when you use the CDK with an IDE or with an editor, having a strongly typed language helps because it guides you to what you need to, in the different options when you build an application, when you build an instance, when you build a security group, for example. So a strongly typed language like TypeScript makes a lot of sense. So our project will have a few folders. In the lib folder, we will put all the CloudFormation stack that this application is going to create. So we have separate stack that will contain some of the components, like the Amplify stack, the backend, and so on. And then we have the backend application that we want to migrate without a lot of changes. So for now, we just copy the full backend application of our e-commerce platform into the backend app directory without any change. For the front end, we are using React. So we are going to take all the code of the source code of the React application, and we are going to put it into a GitHub repo. And we will see that basically the only change we are going to do is going to, at first, is going to add this Amplify YAML file. It is a configuration file for Amplify, but we'll get into why that is useful and what kind of information it contains. So let's start migrating the first component. So for the database, we have MongoDB. Can we change the database without changing the code of the application? No. So we are going to keep MongoDB as our database. We want a serverless option. So the best serverless option today for MongoDB is MongoDB Atlas. This offering that MongoDB does on AWS. And this solution, you can implement it with a serverless option that can scale down to 0 as, for our requirement. To migrate, there are different options. In this case, our database is not huge, so we can start by creating a MongoDB Atlas cluster, and then we can just dump the current database, and then we can restore it on the new database. So a very easy migration. In case you can't stop the store for some time and you want to do a live migration, there are other options. Not everything is supported by Atlas Serverless, but there are other options that you can apply both with Mongo, both with other with MongoDB, and both with other databases like DocumentDB. At this point, we have another database, so the only change we have to do in our code is to change the pointer to the database, so the connection URL that MongoDB is using. And with this change, we migrated the database, as promised, with as many little changes as possible.
So now it comes to the backend migration. And because we want a serverless app, we want to scale to 0, we want to not handle availability of our application, we want that all taken care of by AWS. I was thinking that Fargate and AppRunner are good candidates for that, and as well as Lambda, because Lambda is our serverless offering. So looking at the migration requirements, I can see that Fargate and AppRunner are quite good, but they don't scale to 0. They don't align to my migration requirements. If you need and you don't care about the scaling to 0, these are awesome options for doing the lift and shift, because basically you containerize your application, you put them in the cloud. But if you really want to adhere to your requirements, then you might need to look into Lambda that adheres to everything. And now you will be wondering, how can I grab a web application and put it in Lambda? That doesn't work. And I will tell you, yes, there is a way. There is a library, an open source tool to run web applications on Lambda called the AWS Lambda Web Adapter. And what this thing does is it sits between the event that invokes the Lambda function and then converts it into something that a web application can understand, like an HTTP, HTTP1 or HTTP2. This thing is built with Rust, and it's very safe and very efficient. The code that is here, don't worry too much, I will send all the links at the end. So, this extension, this is an extension for your Lambda applications, work with API gateway, load balancers, and Lambda functions URLs that invoke your Lambda function, and then that gets transformed into whatever your web application can take. So the web application, it sits there, you don't need to change it. So this is supported for zip packages and container images, any web framework that can take HTTP and HTTP2, any programming language, and the best thing is that you can develop this and run it locally. So my Express application, I can run npm start locally, do all the changes, and then push it to Lambda, and it's a great developer experience. So if you want to run your PHP web app, you can do it with Web Adapter, and it's totally the same solution I'm showing you for Node. You can do it whatever programming language, whatever web framework. So let's see how this works in action. So this is the Lambda execution environment lifecycle. It has two parts. The initialization part that usually happens during the call start, and then the invocation part that is the one that is responding to the event. During the initialization time is when the extension will boot up. And then in the first bit of the invocation, the web application is going to load. So in the case of our Node application, what will happen is that we will have the database connection getting created, the routes getting created, the connectors, whatever you need, it will get all created. And at the same time, the extension is going to check the kind of readiness endpoint to make sure that your application is ready. It will do that every 10 milliseconds. And when that readiness endpoint returns at 200, then the adapter will grab your invocation, transform it into an HTTP request, and pass it to your application. You can take advantage of an asynchronous invocation. And this is the asynchronous initialization, sorry. And this is great, because you can take advantage of that 10 seconds of free initialization that Lambda provides in order to not only boot up your extension, but also start your web application. So you can do your readiness check and everything, and when that readiness check passes, then the invocation will start, and the adapter will kind of pass that HTTP request to the web app, and then the route will get processed. So in that way, you can really get very fast initializations of your web applications on Lambda. So now we can adhere to the migration requirements using Lambda. We don't need to worry about the availability, because that's one of the intrinsic characteristics of serverless services. You can make a few changes as possible, because you just grab your application and you throw it into Lambda. You configure as little infrastructure as possible, just a Lambda function with an extension, and your environment now can scale to 0. So how we do this? Well, we are building with CDK, so the first thing we need to do is to bring the Lambda layer. The version of the layer might be out of date. You need to check what is the latest one, because time passes and things get updated. And then the next thing you need to do is to add that extension, that layer, into your Lambda function. We have the environmental variables there. You can see the async init. I'm using that one. And then the Rust log, that defines the level of logs that you have in the extension. So if you have any problem or you need to troubleshoot, you can put that into the bug. You can see the code is pointing to that backend app folder that Danilo just grabbed and throw into our CDK application. And then you can see there that the handler has the run.js. And what is that run.js? It's a file that you need to create in your backend application that will tell how the web application starts. So in my case, I'm running Node, so I will do node index.js. And that's how I run my application in my terminal as well. So now our backend is ready, but we need to do the API as well. And for APIs, we have many options. Because we are using Lambda Web Adapter, we need to choose between API Gateway, Load Balancer, or Functions URLs. These three work very well, and they have different characteristics. But for this demo, I want to show you Lambda Functions URL. A disclaimer, if you want to do this and you have an application that you want to extend and you need more complex APIs, maybe checking API Gateway will help you, because API Gateway provides a lot of security mechanisms and a lot of monitoring mechanisms that Functions Lambda URLs doesn't provide. So I will just use that because our application is very simple, but if you really need to go to production for big applications that you're planning to do the Strangler pattern and you're planning to extend and you're planning really to work for many years with it, maybe API Gateway will help you. So analyze the difference, what is better for you. But if you don't know what Lambda Functions URLs are, they are a new way that we announced in the spring on how to invoke Lambda functions with an HTTP request. They are super simple. They are part of the Lambda service, and they are really, really simple to use. You just basically create them. They will be appearing in your console, so you will always know what is the function URL. And that will invoke the Lambda function. So it's a super simple way to start. And it comes with a lot of interesting characteristics. For example, the authentication mechanism is quite simple, but there is one that is using IAM, so you need to have the right IAM permissions in order to invoke the function. It also comes with a CORS configuration. We all love CORS. So as we are going to use this configuration because we are calling this API from a website. They are in different domains, so well, we need to do that. Then it has the input payload management, so you can do path, you can do HTTP methods, you can do query string parameters, and that will get into your function. And the cool thing here is when you're working with the Lambda Web Adapter, all these paths are going to be translated into the right routes inside your web application. So for example, the application that Danilo was showing, there is an URL called, a path called getProduct, and then this getProduct basically is a path and an HTTP method. Inside my application is a route, and then the web adapter will route the traffic from this input. The same with query string parameters, it will pass through. And it also has some management of response, so if you don't put any response and you're using Lambda functions URL, it will just assume that everything is fine and it will return the body. But in the case, for example, of Lambda Web Adapter, in this getProduct thing, when you return a 404, the product is not found, then the response will get translated into Lambda function. So Lambda functions URLs comes with 4 metrics that you can check. So these are quite good for monitoring what is your application doing, the amount of requests, errors, and then the latency. So you can create alarms and you can create dashboards around these metrics. And finally, it's the limits. And here is where it becomes very interesting. The payload is 6 megabytes response and request payload size. The amount of URLs you can have is the same amount of lambdas that you have in your account, by default 10,000. You can always increase that quota. And the timeout is 15 minutes. So that's quite new, and that's a big difference with API Gateway. There is no additional cost on using Lambda functions URLs. So basically, the cost, they are attached to Lambda, so they don't have any extra. No more timeouts and no additional payload limits. And with that, we can configure it in CDK by basically creating a function URL and attaching it to Lambda. We grab the authentication. We don't put any. We just leave it to none. We will do some internally in the application. I will show you later. And then we define the CORS. And with that, we have the backend.
Awesome. So now we have a backend that is working, but we still need a way to reach this backend. So let's look how we can migrate the web app, so the front end. The front end is built with React, so we need a place where we can host the front end in a secure way, in a fast way, low latency for our customer, and we need to manage updates. So in case we need to update the application, we want to have the update as quickly as possible. So there are two options here. We can go with the foundational components. We can use Amazon S3 as storage, and then you can use a content delivery network like Cloudflare to accelerate the distribution. Or we can use Amplify. AWS Amplify basically manage this for us, and in this case, it's the choice we are making. With Amplify, you have a tool for full stack development that can help you in the build phase. And in the build phase, it can configure for you some AWS services that you need, like for authentication, for example. And then it can help you ship what you're building and scale it, because everything that is built with Amplify, Amplify will create a template that then you can extend and you can update with your own configurations. Actually, in this case, we are going to use only one part of Amplify, that is the hosting component of Amplify, at least in this first stage. The hosting part will basically manage the storage and the content delivery network for you, but will add some really unique features that simplify the life of a developer. For example, it's going to manage automatically the unique naming of files if you do an update. So if you have a content delivery network and you do an update of multiple files because they are the component of your application, what it can happen is that they are cached differently, and your client can download different versions of files, like one file from the last version and one file from a previous version. This is something that normally you want to avoid. Amplify will automatically create unique names for the files that you deploy every time, so that the cache will automatically recognize each version independently, and you don't need to do anything about that. It's embedded in the hosting feature. So only that part justifies the use of Amplify. So we are going to use the web hosting here, and when we use web hosting, we can use the CLI or the web console to manage the configuration and the deployment of the different versions of our application. So we can start now with the AWS CDK to create the Amplify app. So we create the Amplify app, and as you remember, we copied all the files of the source React application into a GitHub repo, and now we are going to link this GitHub repo with the Amplify app. So, and we give them the CDK credentials to access this repo. And then we create environment variables that we use for configuration. So, for example, this is a front-end application that is going to run inside a browser. So the browser, when it runs inside a browser, it needs to know in which AWS region the application is, the backend application is running, and it needs to know what's the URL of the backend server that Marcia just migrated to connect and call the API. So this is some configuration that depends on the environment that you are going to create. And then we need to link the GitHub repo with the branch, so that when we deploy, for example, for production, we are going to use the main branch, and it's going to be used for the deployment. As I mentioned before, we can add a configuration file, amplify.yaml, that will automate the build and deployment phase for us. So the first part, that is probably the most important, is we need to explain to Amplify how to build our front-end code. This depends on the framework that you use. So in case of React, we are going to use NPM, but you can replace NPM with your favorite web packaging tool if you want. We are going to use NPM CI that is similar to NPM install, but requires a package log file. The package log file describes all the versions of the dependencies. That always something complex when you manage JavaScript code. And in this way, NPM CI is going to have a consistent way to rebuild the application, always with the same versions, unless you update the package log file. And then in the build file, we are going to populate from the environment variable that are passed to the build environment, an environment configuration file that is going to be passed to the application, the .env file, so that the application will find the variables that it needs, so the environment variables that it needs, such as the region and the backend URL. And then we run the build, and then we need to tell to Amplify what are the artifacts of this build process, so where you can find the file that are part of the artifacts, and which part of these artifacts can be cached, like the node modules, so that this speeds up the next update of the application. From the console, we can start the deployment to one or more environment, and we can monitor the deployment as it goes through the different stages from the build up to the deployment to the actual hosting platform. And each environment, you can configure the environment variables that we saw before, and these environment variables can include configurations such as what S3 bucket to use, or we will see for authentication what identity pool for Cognito to use for authentication, and so on. And with this,
we are done. We are done.
We are done.
Yeah.
We can go. We finished
30 minutes earlier.
30 minutes earlier.
Yeah. Are we done?
Do you think everything works as we expect?
I don't know. Maybe we should see.
OK, let's do some tests.
So there is some issues. There's always some issues. Let's look at the first one. So this is our migrated system. Looks good. It's an amplifier. You can see that. But let's see what happens when we log in. Maybe you can spot the problem. Let's see. There I come. I have a user. It was working in my machine. I put the username, and I put the password. This was working locally. But what happens? I log in or not? I don't know. You know? But what should happen is a typical stateful, stateless problem. Our web application, before being in the serverless domain, was stateful. It was using the memory, and it was one backend that could rely on its memory. Now, we might have like 5 different Lambda functions executing to fulfill that page. So what happens? The login comes in. It saves the user session in the memory. Then the get products come in, starts a new Lambda function. There is no user in the memory. Then the get menu, that is the one that is populating the menu on the top, comes in. There is no user in the memory. I will not show you the menu for a log user. You are not logged. So this is typical when we are going to this environment. Serverless Lambda functions are stateless. You cannot rely on the memory. So you need to do some things in order to address that problem. A typical solution: extract the authentication system from whatever your backend is doing, take it somewhere else, and make it stateless or figure it out. Another simpler solution is to use a Redis like memcache or something like that to grab that memory that your application has and put it outside, and that can solve the problem. Or then another solution can be using a managed authentication and authorization service like Cognito or Auth0 that will handle everything for you. If we look at the first 2 options, we will see that they don't adhere that much to our migration requirements, because if you use a Redis-like solution like memcache, you need to think about availability. You need to make a lot of changes to your application code if you're going to create your own microservice, or even if you're going to extract the user session database. And you might need to configure a lot of infrastructure even with these 2. And let's not talk about scaling to 0. So maybe we need a managed solution. Managed like Cognito, Auth0. These are great, and they adhere to almost all our migration requirements. And here is when we need to start making some changes to our code. But you will see that the changes are very, very minimal, and it's not that bad. So for solving this problem, I pick Amazon Cognito. And why? Well, because I like to build all my infrastructure in CDK, and Cognito is really simple to work with it. And also, it works very well with Amplify. So it integrates super natively, so I don't need to worry a lot. So if you don't know what Cognito is, it's basically a user directory that provides credentials and access to different AWS services. So if it's the first time that you hear about Cognito, there's 2 concepts that you need to know. The Amazon Cognito user pools, that is the user directory. So you can create your own user directory, bringing all the names and passwords and data of the users. Or you can use federated identities. So the password and the user data is handled, I don't know, by Google, Facebook, Amazon. And you just connect them that these ones are registered in your application. And the second part is the Amazon identity pools. And the identity pools is providing AWS temporary credentials to your users. And you might be thinking, why my users might need AWS temporary credentials? That's a great question. They need to do anything, because in AWS, if you don't have permissions to do anything, you cannot do it. So imagine that you have an application, like the one we have, that users need to upload a picture to S3. They cannot do it if they don't have permissions. Imagine an application where users need to be able to see a non-public S3 image. They need to have permissions. They need to invoke a Lambda function. They need to have permissions. They need to query So even if they are using the AWS services from a website, if you're exposing those services, they need to have credentials. So how we start with CDK? The first thing we want to define is the user pool. And there are 3 things I want to configure here. The first one is that they can register by themselves. The second is that they will receive this email that validates the email. And the third one is that the email is their username. I have a full video on what is all these configurations, so if you want to deep dive, I'll leave you the link at the end. But that's the first thing we want to configure. The second one is the identity pool. And here, the most important thing you want to configure is the allow authenticated identities. And that means also give credentials to my users that are not registered, to my guest users. Because if you want to provide images to those guest users, they need permissions. The next step is to create those policies for authenticated users and unauthenticated users, basically telling IAM what they can do and what they cannot do, or basically what they can do, because usually that's how we create the policies. And then with all this beautiful code, you connect everything together. I will not get into that now, but go and check the video if you need to do it. So then we need to make changes, I told you at the beginning. Where we need to make changes? First, in the front end. Now, our front end will do the login, the logout, the registration, and getting the access token using Cognito. Before, all those operations were happening against our backend. So when the front end wanted to log in, they were calling the backend. When they want to log out, they call the backend. Now, we are going to change that, and we are going to use directly Cognito. The other changes we need to do is now our access tokens for our backend are generated against Cognito. So now when we get a request with an access token generated by Cognito, we need to have a method to validate that access token. So that's what we need to change in our backend. Instead of validating the access token against our own operations and our own systems that we have in the web app, we want to put it against Cognito. So I will show you how to do the login. And for the login, we are going to use a library from Amplify called the Auth library. And this is a library that will take care of everything, the login, the logout, the registration, and getting the access token. For using this library, the way that we have created the Amplify application that is using CDK, we need to configure manually this library. And for that, we just basically need to connect all these fields with their respective environmental variable that we have been passing early, for example, in the moment that Danilo created the Amplify application. Here we are passing the identity pool, the user pool, and all this information. Then we want to do the registration. The registration is, again, using the authentication library. But here, I'm doing a trick. I'm also calling the backend. And you might be wondering, why? Because I don't want to change the backend. I want it to stay the same. And if I start doing all the registration in the Cognito, and I don't call the registration on the backend, my backend is really relying on those users to be created and stored in the existing internal database. If I don't create the users, then my backend will start failing. And because I don't want to change it, we are in a lift and shift situation, I just call the backend, and I let it register 2 times. The other thing we want to do in the front end is create the access token. And for that, we are adding that access token header into our requests. The requests are going to the backend. There is a few requests that need to be authenticated, like doing a purchase, like seeing your payment history, like uploading a product, all these things. You need to be a registered user. And for that, you need to have a valid access token. We are, again, using the Amplify Auth library for that. And then we are passing that, getting the access token, putting it in an authorization header, and passing it to the backend in our request. So good. Now our backend receives an access token created by Cognito. But the backend doesn't know what to do with it. The backend was expecting an access token created by itself that the front end is passing. The way that I architected the original application, I'm using here a good practice, so it's easier. I'm using a middleware. A middleware basically will grab all the requests that needs to be authenticated and will verify that the access token is correct. So for this use case, I'm going just to change the middleware. And this is one of the changes I'm doing in the backend. Very few changes. And this is one. I'm going to change that authentication middleware that instead of pointing to my internal access token solution validation, I will point to Cognito. And in that way, everything will work. The key here is to return exactly the same what the authentication middleware was returning, so I don't need to do any other changes. I know this is very specific for my application, but I hope this helps you to understand the decisions that you need to take when you are doing a migration with lift and shift. It's never all possible to grab an application and throw it into a new environment. You need to do some changes, but you can do them smartly and get around. But we still have one more issue.
Do you think?
I think so.
We solved almost everything. So let's try, for example, to upload a picture. So I create a new product, and I want to upload a new picture of my product. OK, and again, nothing happens. So something is broken again. So what happened? Oh, well, the old application was running in a server, so it had an upload directory where it was expecting to upload the files. Now this upload directory is inside the Lambda code, and that code cannot be updated first. You need to reconfigure the function and re-upload the code of the function, but that was, of course, doesn't make any sense from a development perspective. And also, you have a limit because the maximum size, if you use a container image with Lambda, is 10 gigabytes. We have to say that this was probably not working very well previously as well, because if you had more than one server, you would have the same problem with the upload directory, and you would need something like a shared file system, even if you run on a traditional server. And in fact, if we look at the possible solutions, we can use Amazon EFS as a shared file system, or you can use S3 to host the images and CloudFront to distribute the images to the user. So let's see the pros and cons of the two solutions. So if we use EFS, we still need to think about subnets. We need to connect the Lambda function to a VPC to reach the EFS file system. So there's a little bit of complexity there that maybe we want to avoid. From a code perspective, probably everything works because it's a POSIX file system, EFS, so you can just read and write from the shared file system without issues. And I have to say that the last update of EFS 2 days ago, during reInvent of the dynamic throughput, it also makes EFS a little bit more compelling than when we built this deck. But again, I think another big problem of using EFS is that every images would be served through the Lambda function. So we were going to use the Lambda function as a web server for all static images. So that's not efficient. You would pay probably a lot of cost for just moving bytes around. So EFS and CloudFront, from that perspective, require a little bit more code changes. But for the rest, they are completely abstract from their regional services. I don't have to think about availability zones and so on. So CloudFront, as I mentioned before, is a content delivery network. So it's very good in accelerating the distribution of static and dynamic content to your end user. It basically has many more. This is the classical image. When you put it into a slide deck, it becomes old before you save the deck. But at the time, there were more than 300 edge locations distributed across the world in something like 47 countries. And this edge location will receive the request from the user, and then will ask to the origin, that in this case is the S3 bucket where I store the original image for the content. And then based on the HTTP header that tells how to cache that content, we'll keep it in the edge location. And the next request will be very fast because the user reaches the edge location maybe in the same town where he lives and gets the content back super quickly. So this is the solution we want to build. From a CDK perspective, we can create an S3 bucket. We can configure cores for the bucket. We can also configure the time to live for the in-flight request for cores. So we can configure anything in code. Also, CDK, as you know, has very good defaults. So creating a CloudFront distribution is very few lines of code. It's super simple. And then eventually, you can customize the distribution later when you start to have a high throughput on your application. Let's see the changes to the application. So first, we need to change the way we upload files. We're not uploading to a directory anymore, so we need to use some APIs to upload to S3. And luckily, Amplify helps again, because Amplify has a storage library that we can use. We configure in a similar way as we've seen before. And then we can use storage put to put the file on an S3 bucket. And again, to do this, we will need permissions and the temporary credentials that Marsha mentioned before. And then we need a configuration file that will tell to Amplify library which bucket to use, in which region is the bucket. We solved the write problem, how to upload to S3. Now we have to solve the read problem, how to read images from S3 in our code. And here, React as a framework helps us, because we can create a component with React that will automatically build the new path of the images when it goes through CloudFront, and then we return the image tag for the browser, replacing the path with the path through the CDN, and that goes then to S3 through CloudFront. And then I need to replace all the part where I used to use the image tag with this new component, and that's it. So it's just a sort of automatic replacement of all the occurrences. And with this, we finally managed to migrate everything, and everything works. If I start to use the different features, we can browse the catalog, we can add things to our catalog, we can log in, log out, we can upload new images. Everything works.
Yeah.
And at this point, I will start to think maybe this can be expensive.
I don't know. We need to ask that. But if you see there, the whole thing is working, and everything but the typing that you're seeing in the video is real time, because I'm a little dyslexic, so I cannot show you how slow I type. But everything else is real time, and it works quite fast. All the search and filtering mechanisms that you're seeing in this website is done on the backend. So basically, every time I'm doing a filtering, I'm calling Lambda. I'm a backend developer. I don't know how to do front-end things. So all these search are backend calls and calls to Lambda. So next question you might be wondering, like Danilo was thinking, is this expensive? So I ran some calculations, and basically, one thing you need to know about serverless and AWS is that AWS offers a super generous, forever free tier for your AWS services. So Lambda is free, Cognito, Amplify, they all have really good free tiers. So that means that you need to use a lot of it to start paying. There is two places where you will start paying. First one, Secret Manager. Secret Manager is expensive. We all know that. It comes with a lot of benefits, and if you enjoy those benefits, you will take a lot of advantage. I'm using Secret Manager here to store 2 secrets. I like it because it integrates very easily with CDK, and it solves a lot of my problems. But you can use Parameter Store that is way cheaper to replace that and have a cheaper offering. So Secret Manager for the 2 secrets costs 1.16 in US East 1. And then the other thing I'm kind of paying here is the build time of Amplify. That's time that the application is building. And for this demo, I'm building once a week. But if you need to build less, you will pay less, and you can check what is the free tier for building. So the total is $211 per month. So it's quite a cheap web application that scales up and down to 0. But now you might be wondering, does this work? Does this perform? That's a good question. That's one of the most popular questions I got asked when I started building this. So for solving that question, I ran a front-end check with a page speed insights. That is a tool that allows you to check how your application is performing. It will give you a grade according to that. And then for the backend, I ran load test to make sure that my application is responding and to understand the bottlenecks and the scalability limitations of my application. And this is something that I would recommend everybody building serverless applications to run a load test, but we will get there in a moment. So let's look at the front-end analysis. So this is real time. I just put the URL. Don't look at the mobile because I have not optimized. Let's look at the desktop. And here you can see that the response is 97. The grade is 97 over 100. The response time is quite good. And I will tell you the secret here. The secret is right image sizing and right image format. You can optimize the backend as much as you want, but if you have the wrong images, then this grade goes down very fast. But we will talk about that in a moment. Then for the backend, load testing. Load testing is fundamental. For that, I try artillery.io. Artillery is a library that allows you to run load tests in different APIs, and I've been using this one for many years. That was one of the few reasons why I will start an instance, but luckily this summer, they allow you to run load testing using Lambda functions. The only limitation is you can run it for 15 minutes your test, but that's more than enough to run different scenarios and to play around with your applications. It's super easy to configure. You configure scenarios. You can configure how the scenarios will ramp up, how they will start the request arriving, in which rate, and you can make it very, very complex. So I use this tool. I use this tool to understand the request time of my application. You already saw that the application is very responsive. But I use this tool to understand the bottlenecks. You will see when you get the code, and if you deploy it, there is a whole CloudWatch dashboard where I will provide you with a lot of metrics and a lot of dashboards that are built in the application, because it's super important for you to understand what the limitations of your applications are. In this application, the limitation starts appearing around the 400 concurrent Lambda invocations. And why 400? Because that's the amount of free Mongo connections you have for the free Atlas cluster that we are using. So now it's time to think about, is that enough for you? If it is, then you're good. But you need to make sure that you know your limits. If it's not, what's next? How I solve that problem? And here is where the strangle pattern comes into place. For example, now you are in serverless. You can start refactoring that product API, that get product. When you start analyzing and looking at the metrics, you will realize that 90% of the calls are get product. So what if you apply a different pattern that doesn't rely on connecting to the database every time you want to do a get product? Now you can do it because you are in the serverless world. It's quite easy to extract that, maybe to another Lambda function, and play with more static solutions. That's something to play around. Another thing you can play around is with event-driven architectures. I mentioned you that the speed and the performance all goes to web format, WebP, of our images, and the right sizing. What if the user comes and put an image that is like 10 megabytes for super K resolution, magic, boom, 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 and kills your performance? Well, now you can start adding these event-driven scenarios. When a user uploads a picture to S3, a Lambda function gets triggered that will reformat the picture in the right sizing, and then you will use that one, and you will always have a nice performance. You are in control, and that's very easy to implement. What next? Now you want to extend your application. You want to add a paywall, or you want to add a recommendation system. You want to start using artificial intelligence APIs that AWS provides. You can start building those as Lambda functions or direct integrations, and it's very, very simple because you are already in the serverless realm, so you can start taking advantage of everything. So I promise you the links and everything, so you can get like 11 video tutorials on how I build this with all the different services, so you will get bored of my face. So take a picture of that, and with that, I don't know how you feel, Danilo. Are we ready to lift and shift?
I think it's doable, yes.
It's doable, yes. So I hope you're happy, you learned something new, and thank you very much.
Thank you.